Okay. All right, let me get my mouse over this side. And my pen and my tablet. Okay, so what we are going to do today is the final tutorial, which is on chi-square test and Fisher exact test. Okay, so let's go back to the basics. When do you use chi-square test? When do you use chi-square test? Anyone? Training?
For non-parametric.
Chi-square test, okay, first is non-parametric. Any others?
The ordinal data.
Metric, okay. So it's normally used for ordinal or nominal data.
Teacher, are you writing something? I cannot see your
Okay,
screen.
you can see, so I'm not, okay. Okay, this will look better. So yeah, ordinal or nominal data. Okay, so generally nominal or ordinal data are non-parametric. Okay. So these are the two main users of this. Actually, when you use chi-square test, and actually the third most important one is the data is generally categorical. Okay. Categorical, you are actually saying that it's nominal or ordinal already. Okay. So versus when do you use Fisher exact test? When do you use Fisher exact test? Somebody, who are the rest? Okay, how do we get back? Okay, okay. So Jen, when do you use Fisher exact test?
When one of the samples the thing is less than 5.
What thing is less than 5?
You know the n, is it?
Okay.
No, yeah.
Correct. So when count is less than 5. Okay. So in your tutorial, no, your practical. So if it's less than 5, only when you have more than 2 categories. Okay. More than 2 categories means that your degrees of freedom is more than 1. Okay. However, the count have to be, if the count is less than 10, when the degree of freedom equals to 1. That means only 2 categories. So which means that your Fisher exact test is for small sample size. Okay. For large sample size, you use your chi-square test. That's the main reason. Okay. However, there's actually a lot of problems with Fisher exact test. You realize that Fisher exact test is actually not easy to calculate. Okay, there's only one question with Fisher exact test, which is your question 4. Okay. So anybody still confused with these two tests? When do you use which one? Okay. Okay, so how do you calculate your chi-square test? Okay, so let's go back. How to do your chi-square test? The first thing is you need to get your expected count. So this expected count comes from your null hypothesis. Okay, then you have another one called observed count. Observed count is essentially your data. From then on, the third step, you do your Chi-Square Statistic, which is essentially the observed minus expected square divide by expected. Okay. Your degrees of freedom. How do you get your degrees of freedom for Chi-Square test? Okay, Vivian? What is degrees of freedom for Chi-Square test? Yeah, say something. Okay, probably lost. Lawrence, what is degrees of freedom for Chi-Square test?
Is it sample minus 1?
It's not sample minus 1, that's the problem. Chi-Square test is degrees of freedom, not sample minus 1. Okay, you are very used to having most tests, degrees of freedom is n minus 1. This you use it for your t-test, you use it for your ANOVA. But Chi-Square test, degrees of freedom is not n minus 1. Can somebody help Lawrence?
Is it a number of category?
Number of category minus 1, correct. Okay, so this is very important. Don't mix it up. It's actually the number of category minus 1. Okay, so this is very important. A lot of students have the tendency to mix it up. Okay, so with that, we can actually do question 1. Okay, question 1. Raise. Question 1. Okay, so question 1. What is the problem with? Is there a mistake or what is the issue there? Okay, maybe let's have who is R. Zuri. So what is there any issue with question 1 or what is it a problem?
I'm not sure.
Not sure. Okay, who is sure? Anyone? Okay, who is this? Katuni person? Hello, Mr. Cartoon. Who are you? Keith.
Yes, sure.
What?
I don't know.
What are you mumbling?
I don't know.
You don't know. Okay. Okay. All right. So Keith do not know. Faith?
The expected and observed values cannot be in percentage.
All right. Okay. So the mistake is the expected and observed values cannot be percentage or ratio. Okay. But in this case, it's percentage. But ratio is also not possible. Okay. You actually must use the frequency. Okay. Or the frequency actually means the count, the actual count. So this is very important. I mentioned this in the lab session already. Okay, so anyone do not know that why you cannot use percentage or ratio? Okay, so at least Zuri and Keith do not know. Anybody else do not know why you cannot use percentage? Is there any reason? Okay, let's look at this. Let me just go out again and show you this example. So this is a very important example. Okay. So let me just have this situation. So my question is the proportion or rather, let me just rewrite it. Okay. In the year 2019, is the proportion of male births equals to female proportion of female births. Okay, so let's say this is the question we want to have. Then what will be the hypothesis? Okay, Keith, what is the hypothesis? What is the null hypothesis?
One sec,
What?
one sec.
What is Keith trying to say? Are you in the toilet or something? Okay, let's get the next person. Why are you in the toilet? Okay. Joey? What's the number? Yeah.
I think that is equal.
Huh?
Wait,
So the question is, in 2009, is the proportion of male births equal to the proportion of female births? So based on this question, how do you construct the null hypothesis?
yeah, I say I think it's equal, like the be the mean.
Okay, so the null hypothesis is the proportion of male births equals to the proportion of female births. Okay, that's it. Okay, so from here, what is the alternate hypothesis? So let's, Jody, what will be the alternate hypothesis?
That is not equal.
Not equals, correct. So proportion of male births is not equals to the proportion of female births. Okay, so that we can actually construct chi-square test. However, where do we find the data? Okay, let's get the data. Okay. So this is the data that we have. The data says that male, females. Okay, and I showed this in the lecture already. No, lab session. Where is this? Where am I? Okay, so here. So we go to the data.gov.sg, which is from Ministry of Home Affairs in ICA, or ICA Home Affairs, and then you look for male births and female births. So these are the exact numbers. So let's put it down and see where do we get. So male births, we have 19,918. Female births, we have 19,361. Okay. Which means that the total we have 39,279. Okay. So let's look at situation number 1. If we use count, okay, in fact here we can actually do our critical value already. Our critical value is a chi-square 0.05, degrees of freedom 1. So that gives you 3.814. So let's highlight this. This is our critical value. Okay. So if we do by count, so we will draw our, so we have males, females, okay, your expected and your observed. So it's 19918, 19361. Okay, expected is the total divide by 2. So you get 1969.5. 1969.5. Okay, no problem with it here. So can somebody help me punch a calculator? What is the Chi-Square statistic? Nine. 19361 minus 1969.5. So can somebody give me the answer? Hey, somebody help me punch the calculator. The rest of people go to
3.953.
3.953? No. Try again. Gerard, got the wrong calculation.
Seven point 912.
7.912? So wrong, eh? Calculate again.
Okay.
This is 7.898.
7.898. 7.899. Okay. So based on this, do you accept or reject the null hypothesis? Critical value is 3.814. Your statistic is 7.898. Do you accept or reject null hypothesis? Gerard? Hey Keith, you get out of toilet already or not?
Washing hand now, 1 minute.
Okay.
Okay, so
Accept or reject null hypothesis?
reject.
Reject null. Correct, right?
Sorry.
Right. So you reject, the conclusion is reject null hypothesis. Okay, so it means that proportion of male births is not equals to the proportion of female births. Okay. But let's look at the second case. What happens if we do the opposite? Let me just find which color is nicer. Okay, let's do green. Okay, so let's say we take by percentage. If you calculate by percentage, okay, let me just highlight a few things. So this is where you get your numbers from. Okay, this, you come to here. Okay, and this, you come to here. Okay, so let me next percent. So you get percentage. If you calculate the percentage of males and females, what is the percentage for males? Take 19918 divide by 39279. What is the percentage? Can somebody help me calculate?
%50.7%.
50.7. So give me 3 decimal places of 50.7 what?
50.709.
0.9%, correct. Okay, how about females? You just 1 minus it, you have 49.291%. Okay, so if we take by percentage, then this is what we are going to get. Males, females. Okay, if you're expected, observed. Here is 50.709. here is 49.291. Expected, because it's equal proportion, you expect to be 50. Okay, so this goes to here. This goes to here. Then your chi-square is essentially 50.709 minus 50 square divided by 50 plus 49.291 minus 50 square divided by 50. Can somebody give me an answer? Okay, somebody give me an answer, whoever you are. This guy, Ivana?
Is it 0.0201?
Correct. So it's 0.0201. Then, based on this, do you accept or reject the null hypothesis? Gerard? Hello?
No.
No means what?
You don't
Accept or reject. Don't reject. So the conclusion is you accept the null hypothesis, do not reject. So which means that here proportion of males equals to the proportion of females. Okay? But this is the wrong conclusion. Okay? Which is why it's very important to note that using percentage is likely to result, I would say slightly, I'll just say may result in wrong conclusion. Okay, so this is very important. It may result in wrong conclusion. That's why we do not use percentage or ratio. We have to use count. Okay, so in the lab session, I've given you one example, so I've given you another example. Okay, please remember such things. Okay, that's the next thing here. Okay, so let's go to question 2. Question 2. Okay, let's see who have done question 2. Let's try this. Okay, Minli, what is your Chi-Square statistic? Hello? Okay, not in. So let's find the other one. Nadia, so let's start from the very beginning. What is the null hypothesis? Yeah, are you there?
The population proportion is the same,
Same what?
like the water, milk.
No. So your hypothesis, your null hypothesis is that in the survey, so you have to write out everything. You have to write out the proportion of survey drinking water
Is 0.43.
0.43, proportion of milk
0.19.
0.19, proportion of juice is
0.15.
0.15, proportion of soda is 0.07, proportion of here 0.07, proportion of others 0.06, and finally proportion of nothing, drinks nothing, is 0.03. Okay. Then what is your alternate hypothesis now? How do you write your alternate hypothesis? Nadia, how do you write your alternate hypothesis?
The proportion is not the same.
Yeah, instead say that proportions are not the same as in the null hypothesis. Okay. All right. So in this case, what is your degree of freedom? Let's have another person. Who was the person that I think of just now? I can't remember. Yeah, Ichana. What is the degrees of freedom here? Ishana, are you there?
Hello, I'm here.
Yes, what's the degrees of freedom?
6.
6, correct. Okay. Then critical value. What's the
0.05.
What? No.
Eh?
Critical value.
Oh. 12.592.
592, correct. Okay. Now, do you have your Chi-Square statistic? Shana, again, do you have Chi-Square statistic? If you calculate
10.8822.
10.8822, correct. So based on this, how many of you did not get 10.8822? Okay. What you should do is you should draw out your table. Okay. So you surveyed this is what, how many people? 200 customers. Okay. So you surveyed 200 customers, you have your observed and your expected. Okay. So water, you have 91, milk, you have 35, juice, 19, soda, 21, beer, you have 13, others, you have 11, nothing, you have 10. So total in this case is 200. So expected you have take 200. So essentially you multiply it up. So here water you expect is 0.43 multiplied by 200, you get 86. Then here is 0.19 multiplied by 200, you get 38. So juice is 0.15 multiplied by 200, you get 30. And soda is 0.07 multiplied by 200, you get 14. Beer is also 0.07 multiplied by 200, you get 14. Okay. Others is 0.06 multiplied by 200, you get 12. And finally 0.03 multiplied by 200, you get 6. Okay, so you should know that this comes to here, you have to multiply accordingly. This comes to here, here. I'm running out of my colors, but should be enough. Yes, this comes to here, Okay, color the wrong thing. Oops, color the wrong thing. Okay, doesn't matter. Okay, color the wrong thing, color the wrong thing, color the wrong thing, color the wrong thing. Oops. Okay, so this comes to this. This comes to this, and the last one. Okay, so then you calculate your Chi-Square Statistic. Okay. So how do you get this answer? You just take your observed 91 minus 86 square divide by 86. Okay, and so on. So conclusion, do you accept or reject null hypothesis? Ishana again. Do you accept or reject null hypothesis?
Fail to reject.
Correct. So since the Chi-Square Statistic is lesser than the critical value, you fail to reject null hypothesis. And you accept null hypothesis. Therefore, so how do you write here? The choices from Indonesian restaurant tally with results from the national survey. Okay, that's it. Okay, any questions for question 2? Okay, question 3 is your genetics question. Talking about genetics. Let's see. Anybody really forget about your genetics? See my name list. I can't see my name list because Okay, anyway, it's called haywire. So we are going back to your monohybrid and dihybrid cross. Anyone forget about monohybrid and dihybrid cross in genetics? Seriously, forget about it. Forgotten about it. When I told Dr. Lake this yesterday, she was pretty upset that some of you forgot about what is monohybrid cross and what is the hybrid cross. And I'm not sure if she's around here because I've invited her to come and slap some of you up. Okay, anyway. So question 3 is your Mendelian genetics. Okay, so your Mendelian genetics says that you produce 3 yellow beans to 1 green beans. Okay. So question 3, what is your null hypothesis? Okay, can you see up already? Danson, what is your null hypothesis?
I never do the tutorial, so
You never do a tutorial.
yeah.
Okay, who have done question 3?
Hello, can you hear me?
Hello, who are you? Vivian. Okay,
Yellow.
Vivian. Yes.
Just now is I never speak to the mic. Yellow is 3/4, green is 1/4.
Okay, proportion of yellow to green is 3:1. Okay, so how about your alternate hypothesis?
The population proportion not the same as null hypothesis.
Yep, population proportion. Proportion not the same as your null hypothesis. Okay, how about your degrees of freedom?
1.
1, right. Then your critical value?
3.841.
Okay. 3.841, 3.84. Okay, 3.84. Okay, just now I did make a mistake because of my. Anyway, let me just go and get my answer. All right, this one. So it's 3.841, not 3.814. Just now my first question, there's a mistake, 3.841. Okay, good. My example. Okay, so then what you have is, what is your Chi-Square statistic? Vivian?
0.904.
904. Okay, all of you should be able to get it. So let's work it out again. You have green, yellow, okay, and you actually have a total. So so how many P's do you count? How many P's are there in all? So your observed is 498,152. So what is the total? 498 plus 512?
650.
650. Good. Okay, so 650 here. So in proportion, you should expect 487.5 and 162.5. Okay, then your chi-square, how do you get this number? It's essentially you take 498 minus 487.5 square divided by 487.5 plus 152 minus 162.5 square divided by 162.5. So this you get 0.904. So what is your conclusion, Vivian? Accept or reject null hypothesis?
Fail to reject.
Correct. So since it's smaller than the critical value, fail to reject null hypothesis. Therefore, experiment Anybody know what Mendel, his job is not planting peas, right? Anybody remember what is his actual job? Gregor Mendel. Anybody know what is his actual job?
Oh, he's a monk, right?
He's a monk. He's not just a monk.
Monk.
He's an abbot. Yeah, basically the head monk. Okay, so it is important because it's only people in the monasteries that have the time to go and do such experiment. Okay, the first scientist that earns money as a scientist is Isaac Newton. Before that, they are all monks and so on. Even Charles Darwin, his Voyage of the Beagles, Charles Darwin goes to different places. He's basically takes 1 year leave from his father not to be a monk. Okay. So yes, a lot of people are actually monks.
Sure.
What?
Yeah, I think your green and yellow need to swap around.
Green and yellow? Did I mix it?
Yeah, for your acceptance
What?
of there.
Hold on now, where am I? Green and yellow. Where's the green? Green, oh yeah, this, correct. So this one, correct. So there's a yellow and the green. Thank you. Okay. Yeah, so don't be surprised if you're interested to be a scientist and you don't make it rich, because scientists are not supposed to be very rich. Okay. All right, question 4. Let's go back. Anyone actually have a problem with doing question 4? Please raise up your hands first. How many do not know how to do question 4 or have a massive problem trying to understand what is question 4? Okay, raise up your hand, so I know how many people. Jen, don't be shy. This is the first time you're doing it, Keith. Okay, Vivian.
Sorry, Chia, can you repeat your question again?
My question is, do you know how to do question 4? If not, raise up your hands. Or you have a problem doing question 4? Okay. All right, question 4 is actually not easy because Fisher exact test is very tedious to calculate. Okay, you can put down your hands now. So I'll show you how to do Fisher exact test by hand. Okay. How many of you, when you watch the lecture videos and you read the lecture slides, you actually are able to figure out how to do it yourself? Anyone? Really no one? Okay, Keith.
So what do you say?
What did I say?
Sorry, you talk very fast.
I said, when you watch the lecture and you have the lecture slides, are you able to figure out how to do Fisher exact test?
Oh no, cause the teacher very confusing. He put,
Very confusing.
yeah, he go and put a lot of weird number. Then after that, suddenly got a P table. Then I very confused.
Okay, it's actually okay. So what I'm going to show you is systematically how to do it. That's why the numbers here is a bit small. Huh? So Fisher exact test runs this way. Okay. First, you have to know where you use Fisher exact test. Huh? Okay. So what we are trying to say is, does the statistic supports the claim? Okay. So we are actually trying to say that is whether smoking affects birth weight. Which means that the null hypothesis is that smoking does not affect birth weight. Okay, the alternate hypothesis is then smoking affects birth weight. Okay, now test of independence. When you test something for independence, you are saying that the two variables, smoking and birth weight, are not related to each other, which means that they are not correlated. The alternate hypothesis is they are related or correlated. That affect each other. So far, okay? Then what we have is the data. Let's look at this. The data that we get is this. Smoking, non-smoking. Okay. Less than 2.5 kg and than 2.5 kg in terms of birth weight. So this is our number 2419. Okay, so far no problem, right? However, what we need to do is to add up the numbers first. So we do a column by column. So 2 plus 1 gives you 3. 4 plus 9 gives you what? People, 4 plus 9 give you what?
13.
13?
Wait, 4 plus 9.
13, correct. Okay, 2 plus 4? Come on, 6, and here's 10. Okay, so these are the boundaries. What you need to do is this. Let me choose a step 1. Okay, the steps for doing this is step 1. You actually get all combinations of the contingency table. Okay. Then next, you calculate the probabilities. And here we call this P asterisk of each contingency table. Okay. Then you have the P observed that is equals to the sum of all the P asterisk that are lesser than of the observed. Okay, so this make it very clear. Okay, the sum of all that are lesser than the P asterisk of the observed. So this is the observed. So far, okay? So then let's start with our work. Okay, let's see, let's do this. So what are all the contingency tables that we can construct? Okay, so the first contingency table is this. We start off with 0. If this is 0, in order to get 3, here must be 3, correct? 2 plus 1, so the column must be 3. Now, if this is 0, what is the number here to get 6? That lengthwise, row number 1, you get 6. It will be 6, right? Yeah. So here, go down. If this is 6, what number do you have here to get 13? Get 7. Make sense? Know how this works first or not?
Yes.
Okay, so let's go to the next one. Okay, so we start with 1. Okay, 1, in order to get 3, here will be 2. The total is 6. 6 minus 1, here will be 5. And here will be 8. So we go to 2. So in order, this 2 will be the same thing. 1 here, 4, and 9. Okay, so this, let's highlight here. This is our observed. Okay, then let's do the next one. So here is 3, but 3 here will be 0 already. In order to get 3, the first row to get 6, here will be 3, And then in order to get 13 for this, here will be 10. So this is the final, because there's no 4. 4 here will be -1 already, so it's ridiculous. So these are all the combinations that you have. Now, how do you find their respective probabilities? Okay. The respective probability is using this equation. Okay, let me just take this. Okay. So assuming that you call this as A, B, C, and D. Okay. So the template will be using this. So this is the template. If this is A, B, C, and D, the probability is calculated based on this equation. You take A plus B, the first column, first row, combination of A, multiply by the second row, which is C plus D, combination of C. Then you divide by the total, A plus B plus C plus D, combination of A and C. So that is a formula. Okay. So how do we get here? Let us just take this and we do A plus B. A plus B will be, A plus B is 6. Combination of 0 times C plus D will be 10. Combination 7. Total you have how many? 13, 16. So here n equals to 16, total number.
Your 10C7, is it supposed to be 10C3?
10C3, correct. 10C3. 10C3. Okay. So you add up here is 16 and 3. Okay. So this gives you 0.2143. This you redo again. Here is still 6 C1 times 10 C2. Here is 16 C3. Okay, so this gives you 0.4812. You realize that the denominator is the same. Okay, here is 6C2 times 10C1. Okay, this gives you 0.2679. 63 times 10C0, 16C3. This gives you 0.0357. Okay, so let me highlight a few more things to make it clearer. So this you get 0 comes from here. This 1 comes from here. This 2 comes from here. This 3 comes from here. Okay, then blue, 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 green, 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 orange. So this 3 comes from here. This 2 comes from here. This 1 comes from here. And this 0 comes from here. Okay. So then, after that, you add up. We settled this second step. Next step is you add up all the P asterisk that is less than the observed. So all this is the one that you observe. Which one is lesser? This is lesser. This is not because it's more. This is lesser plus itself. Okay. So which means that the P observed is 0.2143 plus 0.2679 plus 0.0357. That gives you 0.5179. Okay. If this value, if the observed value is less than the critical value, then you accept the null hypothesis. Okay. That means you cannot reject the null hypothesis here because this has to be lesser. Okay. Therefore, in this case, can you accept or reject null hypothesis? Let me do the step 4 for this. Step 4, oops, purple color. Purple, where's the purple? Purple, purple. Okay, so step 4 is reject null hypothesis when P observed is less than alpha. So do you accept or reject null hypothesis? Hello?
Accept.
Accept, correct. So the conclusion is you fail to reject means you accept the null hypothesis. Okay, that smoking doesn't affect childbirth weight. Okay, so that's how you do your facial exact test. It is very tedious. Nobody says it's not tedious. Okay.
Sure, may I ask for the drawing of contingency table? Will they give us or we have to draw?
You have to draw lah.
Okay, thank you.
Yes. Okay. Okay. So are there any questions? Then that's all for today. And I'll see you tomorrow morning for your revision. So please go and do your the past year question, the one that's on LMS already. There are some questions that you do not know how to do because it's out of your syllabus. Those questions you do not do. I think there's only 2 MCQs that you don't do. Okay. All right. Recording.